Hello everyone. In this video, we are going to discuss about rational functions and example 15, which comes under the topic some functions and their graphs from the chapter 2 relations and functions, class 11 max. See, we have already discussed about the constant function, polynomial function, etc. in our previous videos, identity function as well in our previous videos. Which will be available in the playlist, and we will be discussing about the signum function, greatest integer function, modulus function, etc. in the coming videos, which is also available in the playlist, okay. So here you see let us see what is a rational function. See, here the function is defined from real number to real number, r to r, and the function of the form f of x equals some g of x divided by h of x, where g of x and h of x, they are polynomial functions. Okay, they are polynomial functions of x defined in a domain, and h of x not equal to 0, that is denominator not equal to 0. Such a function is actually called as a rational function. Or we can say that rational functions are the functions of the type some f of x divided by g of x, where f of x and g of x are polynomial functions of x defined in a domain where the denominator g of x not equal to 0. So rational functions are actually in the form of ratio. Both the numerator and denominator will be the polynomial functions, and denominator should not be equal to 0. That is a condition for a function to be a rational function. Okay, now let us discuss about the example 15 to get an idea about the rational function, and let us see the nature of the graph. So in example 15, the question is, define a real valued function f from real number set r minus 0 to r. That is, the function is defined from a set of real numbers except 0 to the set of real numbers defined by f of x equals 1 by x. So here the function is f of x is equal to 1 by x, where x belongs to r minus 0. That is, x is actually belongs to the real number set except 0. That is, x is not equal to 0. Then complete the table, and what is the using this definition, then what is the domain range of this function? Also draw the graph of f. So here you see we have x values here, and we want to find out f of x equals 1 by x. F of x means which is actually taken as y value now. So f of x equal to y, which is equal to 1 by x, is to be found out. So when x is equal to minus 2, f of x is actually 1 by x. So 1 by minus 2, 1 by minus 2 is actually minus 0.5. When x is equal to minus 1.5, f of x is 1 by x, that is 1 by minus 1.5, that will be minus 0.6666 like that. So approximated to minus 0.67. When x is equal to minus 1, y, that is f of x is equal to 1 by minus 1, which is minus 1. When x is equal to minus 0.5, y will be 1 by minus 0.5, which is minus 2. When x is equal to minus 0.25, y will be 1 by minus 0.25, which will be minus 4. When x is equal to 0.25, y or f of x will be 4. When x is equal to 0.5, 1 by 0.5 is 2. When x is equal to 1, y value is 1 by 1, which is 1. When x is equal to 1.5, 1 by 1.5 is 0.67. When x is equal to 2, 1 by 2 is 0.5. Okay, so this is how we complete the table. Now let us draw the graph of this function. Alright, for that, here we have x values, here we have x dash, that is negative values of x. Here we have y values, and this is y dash axis. Here you see when x is equal to plus or minus, that is like when x is equal to plus 0.25, y is equal to plus 4. When x is equal to minus 0.25, y is equal to minus 4, like that. Okay, so when x is equal to 0.25, y is equal to 4, so we will get a point here. When x is equal to 0.5, y is equal to 2, so 0.52, we will get a point here. When x is equal to 1 plus 1, y will be equal to plus 1, so 1, 1, we will get a point here. When x is equal to plus 1.5, y will be plus 0.67. So 1.5, 0.67 somewhere here. When x is equal to 2, y will be 0.5. So 2, 0.5, a point here. Okay, so we will get a point here. So when you join all these points, see, we are actually getting a graph like this. Okay. Similarly, for negative values, when x is equal to minus 0.25, y is actually minus 4. So minus 0.25 minus 4, we will get a point here. When x is equal to minus 0.5, y is equal to minus 2. So minus 0.5 minus 2, we will get a point here. When x is equal to minus 1, y is equal to minus 1, we will get a point here. When x is equal to minus 1.5, y is equal to minus 0.67, so we will get a point here. When x is equal to minus 2, y is actually minus 0.5, we will get a point here. So when you join all these points, we are actually getting a graph like this. Okay, this kind of graph or this type of graph, that is actually called as a hyperbola. Okay. Now, what about the domain and range? See, domain is nothing but all the values of x where the function is defined. See, for x equal to 0, the function is not defined because here our function is like f of x equals 1 by x. Okay, our function is f of x equals 1 by x. So, when x equals 0, we get 1 by 0, which is not defined. So, except 0, for all other values of x, the function is defined. So, at x equal to 0, the function f of x is not defined. So, domain is actually the set of real numbers except 0. So, r minus 0. Okay. Similarly, range. Range also you see, range means the y values or f of x values. 0 is not there in the range. Okay. That is, the range is actually the values of y or f of x. See, function approaches to 0. Function approaches to 0. Okay. Here also function approaches to 0. But not 0. So we have to exclude this 0. So range will be the set of all real numbers except 0, r minus 0. Okay. So in this video, we have discussed about the rational functions and example 15. I hope it is clear to you. Thank you.